So I'm now joined by Martyn Flood. Hi, Martyn, how are you?
Hi, I'm good, thanks.
So Martyn, you are the chief engineer behind the design of our fantastic Phono Signature. So
That's right.
welcome very much to the podcast, and thank you very much for joining us today. Now, the relationship that we have is obviously I set a criteria and you guys have to go away and design it all. So I thought maybe for the benefit of the listeners, I'd just kind of recap those that a meeting we initially had. So the primary goals really for this product were sound quality above everything else. That was the prime aim, to make something much better than we had before. I also threw a bit of a curveball at you because I said, look, I want to be able to control the different gain, resistance and capacitor settings from the comfort of my own armchair via remote control, which you guys all kind of went, whoa, how are we going to do that? And then I also said, look, and actually what we want is different settings so that people can connect up to 4 different turntables, which again was something we've never really seen before on a phono stage. And you went away and solved that solution admirably. Perhaps you can start off by explaining kind of what are the engineering challenges behind a phono stage in general that you have to get right to make sure that the sound quality is really, really good.
Okay, the first challenge is really to deal with the fact that there are so many different types of cartridge on the market in terms of output levels, from your high output moving magnet cartridge, which gives typically 5 millivolts.
You say that's high output. I mean, my CD player it gives 2 volts, so it's still pretty small, even if it's moving magnet.
That's high output for a cartridge.
Okay.
5 millivolts, all the way down to 100 microvolts from a high quality moving coil cartridge.
So why does a high quality moving coil cartridge give such a low signal output?
Because you need a very lightweight cantilever to be working against the record, because you want a very low inertia, and the only way to achieve this is to have very few coils wrapped around this cantilever, which gives you a very low output, and the phono amplifier has to deal with this very tiny signal.
Okay, so the theory in cartridge design is essentially the lighter it is, the more accurate it can follow the grooves, but the lower the output signal.
That's exactly right. Yes.
All right. Okay.
Yes.
So you're dealing with this thing that's 100 microns, 100 microvolts. Now, I remember we've talked before about this is the equivalent. If you're turning 100 microvolts into 2 volts, which is what your typical amplifier wants, this is a bit like taking something the size of a CD, so a 5-inch CD, and making it as tall as the Empire State Building. So to give the listeners an idea of the scale of the problem that you're dealing with here.
Yes, you have to take a very, very tiny signal and basically make it very large, so an ordinary amplifier can deal with it.
Okay. And now amplifiers don't amplify, do they? They make copies.
Yes, they make a large scale copy of whatever the incoming signal is.
Okay.
And they do in a variety of ways, but it does require a very high quality amplifier and a very high quality power supply to be able to do that accurately.
Yeah. Okay, so why is power supply quite so important then?
A poorly designed power supply can add noise to the signal, which is not what you want. That's really the main thing. You need a power supply that's very, very low noise, very, very stable, to give you the best possible output signal.
Okay, and I've likened this before to a sort of gourmet chef, because you're making a copy of this signal. The thing that you make the copy from, the ingredients you're using, becomes very, very important to the quality of that actual output signal. So having fantastically clean, beautiful, rigid power which is what you're making this copy out of, is kind of key to that quality process.
You've got to make the absolute best you can of the incoming signal to not lose anything, because there isn't much there to start with.
Right. Okay. So what other tricks do we? So you talked about noise, and the noise floor being very low on this particular product. Have you got what kind of sort of dynamic range and noise are you managing to get out of this design?
We can get up to 110 dB dynamic range out of this unit. It obviously depends a lot on what your settings are and the cartridge and everything else, but it's always substantially lower than the surface noise of the record.
Which is kind of what you're trying to achieve. Okay.
Right, yes.
And so and 110 dynamic range, that's pretty big, isn't it? I mean, what's the dynamic range of embedded in a CD?
Compact disc is 96 dBs.
Okay, so we've got a phono stage that is capable of a bigger dynamic range than all the data that you've got inside a normal CD. So if there is that information there, we can extract it.
That's right, yes.
Okay. So you've talked about low noise. What are you doing inside the design to make sure that you've got such a low noise floor?
Well, the first thing we do is make sure that the incoming signal is buffered and amplified as soon as we can do it. Obviously, we need to have a few things in the way. All the input loading for the cartridge has to be between the input and the first stage. But so long as within a very short distance of the incoming signal, we can provide some amplification for the signal, it's much less likely then to be disturbed by any electromagnetic interference.
Okay, now I know you've got an open phono sig there for me to be able to show the viewers some of the things on the inside. So, and obviously the signal comes in at the back. Are you able to just kind of show us roughly where all this amplification is to demonstrate exactly how short a signal path this actually is?
Okay. Right, what we've got here, if you can see it, is the inside of the back panel of the phono signature. You can see by the size of my finger the amount of the size that this thing is. We've then got a few relays just inside, which is the cartridge loading, and then right down here is the amplification stage. So that's 5 centimeters from the back of the box, hardly any distance at all.
Okay, so all of that amplification is happening at that lower end of the box. Now you mentioned relays there, and relays are kind of like a key part of this design of this product, aren't they? Do you want to talk a little bit more about that?
Relays are by far the best way of switching an audio signal. It also means that you can store their settings in a microprocessor. One of the big advantages of this unit is we can have up to 4 turntables connected, and the microprocessor with its memory can remember what settings you have applied to that and recall them instantly that you switch to that extra input.
Okay, so this was when I threw this. You've got to have 4 turntables connected at once. You immediately went down we've got to design a shed load of relays in route. Did you?
That's the only way to do it.
Yeah, the only way to do that, and of course, turned out to be the most expensive way to do it, of course, because there's this constant battle, isn't there, between management and R&D, with you proposing your high-end, high-cost solutions, and me going away saying, no, you've got to make it perform the same but cost less.
We're always trying to make the best possible product we can make.
Yeah. No, indeed. So, and why are relays so good? I mean, sonically, why are they such an improvement over alternatives?
Relays introduce virtually no distortion, virtually no noise, have no real limits to their bandwidth. They're just like a piece of wire.
Okay, so that they are always the optimal solution. And how many have we got in there? I mean, are you able to sort of get your camera back on there and quickly point out where they are all clustered?
Okay, let's give it a go. Right, looking down here, we've got the 4 relays at the front, sorry, the back of the product here, which select between the 4 inputs. We've then got this bank here, which is the capacitance and resistance settings. We then come on to the next 3 here, which are the gain settings for that first amplification stage. Then we've got the mute relays and some output relays as well down there.
So everywhere you can, you've kind of put relays into the product, really.
Relays, whenever switching is needed, I'll use relays, yes.
So now that must be some pretty clever design there, because I know, having done the maths, the various capacitance and gain settings we've got on this product, we've got about 160 different combinations, which is significantly more than most other phono stages have, where you might have a sort of high low or a 3 capacitance settings. Firstly, why have you gone for so many different options? And secondly, have you managed to kind of build that in without making a much bigger box with thousands more relays in it?
I suppose firstly, the reason we put lots of settings is coming back to my point that there are so many different cartridges on the market.
Yeah.
And to be able to accommodate the settings for all of those, and to give the end user some flexibility in terms of, a lot of cartridge manufacturers will claim a range that you can use, but switching different settings in, it might sound slightly different, and depending on what other combinations of components the user might have in his setup, a different amplifier, different speakers, personal taste, different types of music, different records of different qualities, you can tweak the sound to however you want it with all this combination.
And how have you managed to get so many of those combinations in? Is that just sort of really thinking cleverly through the circuit layout design and where the relays are put?
Where the relays are put, we try and use very small relays so we can get lots and lots into tiny little space.
Right. Okay. That's great. And now, 4 inputs. So obviously we've got the microprocessor remembering all the different settings. So you select a different input and then suddenly all these relays switched and changed to wherever you remembered them. Now, my theory was that people have different arms and cartridges and combos for different types of records, and that's why we wanted to put that in. Is that, in your experience, as the case? I mean, what's the feedback that we've had? Do people, are people out there sitting there with 4 different turntables because they got one for 78s, one for 45s, one for pre-1953 vinyl, and one for post-74 vinyl, or whatever it is?
Some do, some don't. Not everybody will have multiple turntables, but we like to offer next flexibility that this product is for everybody.
But we do know, don't we, that there are lots of different sort of types of vinyl, and therefore, depending on what era these products come from, they tend to sound better on different combos, don't they?
They do, yes. And some people might have a particular turntable with a moving magnet cartridge that they are quite happy to play their old records that they'll find in a junk shop, but they wouldn't let their high quality moving coil cartridge loose on these records for fear it might damage it.
Right. Yeah. No. Exactly. And also, yeah, and especially now with the availability of some, okay, admittedly re-released, but really, heavy vinyl, high quality pressings that you want to, look after, really, don't you?
That's right. Yes.
Yeah. Okay, great. Now, Martin, the other thing I wanted to talk to you a bit about, which always confuses me, is RIIA, which you see
RIAA.
yeah, sorry, RIAA, which you see a lot on all of these things. Which, okay, what does it stand for? And we've done something a bit more smarter, I would say, in our product. So just talk us through that.
The RIAA pre and de-emphasis network was originally conceived back in the early 50s, and its primary reason is so that you can get more playing time on a record.
Right.
Um,
And how's it doing that? What's its emphasizing and de-emphasizing?
it, 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 the low frequencies are attenuated on the record side, and the high frequencies are boosted.
Which makes the groove physically smaller, doesn't it?
Which makes the grooves physically small. You can get a lot of them onto a record, and you can get your 20 minutes playing time. If you recorded it flat, you don't, and you get 5 minutes playing time on a record.
Right.
When we play a record back, we got to do the exact opposite to end up with a flat frequency response.
Yeah.
Now, we know for a fact that record manufacturers don't always strictly follow the RIAA curve, because it would mean an infinite gain of 50 kilohertz, which may sound a very high frequency, but it means a very slight roll off towards the top end of the frequency response. Now, in our RIAA de-emphasis network we put in this product, we account for that, so we get a more accurate frequency response than many other manufacturers would be able to do in theirs.
Okay. Now, you've mentioned 50 kilohertz as well, which brings me on to another point, because the frequency response of this product goes all the way up to 50. Now, the perceived wisdom is that our ears can't really hear anything above 20 kilohertz. So, what's the logic behind making the frequency response, flat all the way up to 50?
The logic is purely from listening tests, really, that we know if we curtail the frequency response too early at 20 kilohertz, it won't sound anything like as good as if we have a flat frequency response up to 50 kilohertz. And that's just purely through listening sessions.
Yeah, I mean, I've been in some of those sessions, so I understand how that works. I mean, there are lots of theories, aren't there? There's theories that you've got harmonics that are folding back into the audio zone. So you might have a harmonics of a 40 kilohertz signal that folds back in below 20 hertz. And there are other theories that say that kind of the timing information in the music is stored in the harmonics of these higher frequencies, and human ears are particularly good at timing and picking out timing. I mean,
it's timing, it's the phase shift that you get on the high frequencies. This all leads to an accurate musical representation.
Yeah, so you have to have all that information coming through in order to get the full gamut of what we want to hear in the audio zone. But
exactly.
There's a cost to that, though, isn't there? Because it's not easy to extend the range that far.
No, you have to have the very best high quality components, very low noise circuitry to be able to do that.
Yeah. Okay. So again, it's another engineering investment which we feel has been worth the payback.
That's right. Yes.
Okay. Now, the last thing I think I wanted to talk to you about is the PSX upgradability. So putting the external power supply on. So the PSX is a external power supply. We supply it to lots of different units. It can be plugged into a whole range of different Cyrus products. When you plug it into the PSX, what's it doing and what kind of benefits can you hear?
The PSX power supply enhances the power supply that's already in the unit and gives a much greater current output, which means much more control of the signal. It's particularly noticeable on the low frequencies. The bass just sounds so much better on a Phono Signature when you're using a PSX power supply.
Okay, and which bits of the circuit is the PSX powering when you plug it in?
All the audio circuitry is enhanced by the PSX.
Okay, then you're leaving all the other bits, the peripheries like the screen and the other bits and pieces to be powered by the internal power supply.
All the control circuitry is same as it was. There's no point in enhancing that. It won't be a brighter screen or anything nicer. It's just down to improving the audio.
Yeah. Okay. And the transformers, both in the product and in the PSXX, they're pretty special as well, aren't they?
These are all custom built transformers. We normally have 2 or 3 different ones. We assess the sound quality, decide which is the best, and go for that.
Okay, but these are all custom built. I mean, even before that process, you've kind of given quite a detailed spec, haven't you, to the supplier to try and make
give a very detailed spec to the supplier, exactly what voltages we want, what the current rating is, obviously the physical size of the product, and we just assess it based on what he turns up with.
Yeah, and of course it annoys the accounts department intensely because it means that a transformer from one product can never be used in another product. So our SKU and bill of raw materials increases exponentially because we have to have a separate transformer for not only each individual product, but then again for the 110 and the 240 volt one. So we're doubling up all the time. So it's not a cheap solution by any stretch of the imagination.
Not,
yeah.
But we just want it to sound the best.
Yeah, no, I agree. I sit here and talk with my semi-accountant's hat on because it's my job as managing director, but ultimately I'm all for it and I sign all the checks because passionate about the sound quality is what it's all about. And we want to produce the best products possible. Martyn, it's been fantastic to talk to you, even from your isolated converted barn, it looks like there. Lovely.
It is, yes, very nice. It's part of the house now.
Fantastic.
And we had it joined on last winter.
Excellent. Okay, well, look, Martyn, look, thanks very much for taking the time out to chat to me today. And I will speak to you again soon. Take care.
Great. Cheers, Simon.
Cheers. Bye.